Hey class, in this video we are going to introduce the concept of molarity as a way to quantify the concentrations of solutions. So as you recall from early on, when we define solution, what we're really talking about is a homogeneous mixture, a mixture that is the same throughout of two or more substances. And when you have a solution, oftentimes you have one of the compounds present in significant excess of the others. All right, so meaning you have much more of one compound relative to the rest of the compounds present. In this case, the compound that's in excess is called the solvent, and all of the components present in the lower amounts are called solutes. And we use the term concentration to essentially give the relative amount of each given solute. And so we're all familiar with this. If you look at, for example, the solution here on the left, you can see that it's much darker than the solution on the right, meaning that there's a lot more of these dissolved little blue particles floating around in that concentrated solution relative to the dilute. Okay, and so this sort of everyday use of the term concentration is useful for comparing substances one to another in some cases. However, for chemistry applications, what we really need to build up is a more rigorous definition of concentration that allows us to quantify exactly how much of those solutes are present. As we'll see, there are actually many different units of concentration. However, in this mini lecture, we're going to touch upon perhaps the most important one, and certainly the one you're going to see more than many of the others, which is this unit of molarity. All right, so molarity is defined as the number of moles of solute in exactly 1 liter of that solution. So we typically denote molarity using this capital M. And so writing out the units here, we have moles of solute over liters of solution. All right. So what we're basically going to do here in the remainder of this mini lecture is work through a handful of example problems that require us, applying this basic definition of molarity. In this first example, we're given 355 milliliters of a soft drink sample, and we're told that this soft drink sample contains 0.133 moles of sucrose or table sugar. We want to use this information to determine what the molar concentration of sucrose is in the beverage. In other words, what's the molarity? So the first step is going to be to basically get our problem in the units of molarity given above, moles and liters. We're given a volume in milliliters, so we're going to divide by 1,000 to get that volume of soft drink in liters. Then we can calculate the molarity by just directly applying this equation that's given above. We have moles given in the problem right up top, and our liters that we just calculated right on bottom. Carry out that division, and we arrive at a final answer of 0.375 molar. Okay, so this is an example of how we can essentially take given information of liters and moles, volume and moles, and use that definition of molarity to directly calculate the molarity of solution. Now, in this next example, what we're going to do is use a given concentration and a given volume to determine how much sugar in moles is present. Okay, so once again, we are going to be using our formula for molarity, which requires volumes being in liters. So our first step is going to be to convert that given 10.0 milliliter quantity of our soft drink here and convert that over to liters. Then we are going to take the given concentration of soft drink, 0.375 molar, and we're going to take this, and I always recommend breaking out those units of molarity and writing out explicitly what we're talking about, moles of sugar over liters of soft drink. And then once you break apart those units, it becomes clear to see that if we take a mole per liter multiply by liters. Well, liters soft drinks cancels out, and we are left in units of moles of sugar. Okay, so it's very important that you're comfortable with applying this definition of molarity, solving a variety of different problems and really relying on unit conversion to help guide your path. Now, in this next problem, we're going to introduce a topic of molar mass that we discussed previously and see how we can weave that into the problem solving process. So in this problem, we are told that we're given a distilled white vinegar solution, and this vinegar solution contains acetic acid, right? Acetic acid is responsible for a lot of properties that we attribute to vinegar. And basically vinegar is this acetic acid dissolved in water. So acetic acid is going to be the solute and water will be the solvent. And we're given a 0.500 liter vinegar solution, and we're told that it contains 25.2 grams of acetic acid. Now we want to use this mass and volume information to determine what the concentration of acetic acid is in units of molarity. All right. So again, relying on our definition of molarity, which is moles of solute over liters of solution, we need to first convert our given quantity of acetic acid in grams using the molar mass to units of moles. So dividing by the molar mass of acetic acid gives us 0.420 moles of acetic acid. All right. Now that we have moles, we can go back, just as we did in the previous problem, to our definition of molarity and directly plug in the calculated value, 0.420 moles of solute, and the given value right here, half a liter, and arrive at our final answer, 0.839 molar. Okay, so that's the basic set of problems I want you guys to focus on. I'm going to go ahead and work through 2 additional examples for those of you that want to keep watching on to get a little bit more practice. In this next example, we are going to have to determine how many grams of sodium chloride, salt, are contained in 0.250 liters of a 5.30 molar solution. All right, so just as we did before, we need to determine first, given that concentration, remember is moles per liter, right, the number of moles of solute, and then figure out, using the molar mass, how many grams are present. So the first step, the moles of solute is going to be given by this concentration, given in the problem, multiplied by the volume of that saltwater solution. Liters will cancel out, and we will be left with units of 1.325 moles of sodium chloride. Once we know the moles of sodium chloride, we can use the molar mass of sodium chloride, and multiplying by the molar mass gives us a final answer of 77.4 grams of sodium chloride. Okay, so solving a similar problem, but just essentially in the opposite direction. This final problem is giving us the concentration of a vinegar solution. We know the concentration, 0.839 molar, and we want to figure out what volume of vinegar would be required to come up with 75.6 grams of acetic acid. So the first step is going to be to take this mass of acetic acid, divide by the molar mass once again, to get the number of moles of our solute acetic acid. Once we know the number of moles of solute, we can divide by the concentration to get a volume. So the moles of acetic acid that we must have in order to come up with that 75 grams is the 1.26 value we calculated in the first step. We're going to divide then by the given concentration right here. The moles of solute is going to cancel out. We'll be left with liters of solution, and we will arrive at our final answer, 1.50 liters of our vinegar solution.